So welcome everybody to another meetup presented by AICG and Data Lakehouse meetup on Snowflake Carolinas Snowflake Meetup Group. And so we're going to be talking about variant data types in Snowflake tonight. And we're starting on time, so as people trickle in, that's okay. We've got everybody muted on login or in sign in. And as we go on, as we talk about every meetup, we've got these great topics, but we just want to make sure everybody's following some key things that keep us all sane. Your video on is optional. Obviously, go on mute like we mentioned. If you have a chat or comment, just put it into everyone unless it's like very specific or needs to be kind of clandestine. And then of course, as you see these posted on Meetup and you get our newsletter, just make sure you're inviting a friend or recommend us to a friend, because we've got a lot of great topics. And get social. We're on Twitter, we're on LinkedIn, we're on Facebook, we're on Instagram. So find us and join us. You might actually win some swag that we have coming out pretty soon. And so in this session, what we're going to be doing is we're going to be talking about variants, kind of their power and purpose. And we're going to get a little technical out, actually. And if we have any questions, we'll dive in a little deeper. But that's why we're kind of saying, hey, it's going to be a quick walkthrough on the variant data type, also known as variants. And again, as you saw from our cover, if you follow the Disney Plus Loki series, right, variants are kind of this exception to the rule, but it's kind of like a case where there's, it kind of branches away from maybe the standard type. And in this case, that type is a data type. And so we'll talk a little bit about those. We'll talk about how we can parse the variant data that we load into a variant data type. We'll talk about how we can copy variant data into a standard relational structure, move things around in variant data types, obviously some other open topics there, and then we'll have some ability to discuss and look at some future events. So as always, we'll do a quick refresher on Snowflake. What is it? So it is an amazing all in the cloud data cloud platform for warehousing your data, doing your traditional data warehousing, even some data lake and data lake storage, data lake analytics and data lake storage capability. We think it's the best place to put your data lake house, and it's a great way to ingest data, govern your data, access your data, and scale almost infinitely any processing or data related tasks that you have on your data. Solves a lot of different problems, all the traditional stuff, even the stuff that we used to do for almost a decade there with big data, looking at things like, Hive and Hadoop. We now take those workloads for ourselves and for our customers and so forth, and we move that into Snowflake just because it solves a lot of problems that we thought were too big to solve in any other shape or form. And now we can do those things almost like magic inside of Snowflake. So great system. And if you ever need any more knowledge or insight into what Snowflake is, just reach out to us and we'll be happy to talk to you about it and really get you guys to a point where you can be successful with your data. Okay, so if we're talking about variants, and we use that term, the variants, objects, arrays, but the data type is actually called a variant data type. I've got a little fancy definition on the right there for you from, I think, Webster's Dictionary. You just kind of have a quick Google search will turn up something for you. But like I mentioned before, it's something that differs in respect from other forms. And it's almost a near perfect name for this data type as it comes from for Snowflake, right? They kind of line this up nicely. And so based on the structure of it, again, it can hold almost any type of unstructured, semi-structured data that you could throw at it. And so those typical formats are JSON, Avro, Parquet, XML, and it's a data type. So it's just like having a string data type or a varchar data type or an integer data type. It's going to be in its own physical column. And so based on that idea, when you're loading any type of any semi-structured, unstructured data, you're typically just going to load it into this one column called whatever you want to call the column, but it's going to be of a variant data type. And so there are some recommended maximums that you want to put in this, because you can imagine you could have a JSON or XML file that's like, 16, maybe it's a gig or in size, right? But in general, if you have a file that contains this information, they're recommending break it up into chunks of 16 megabytes, right? And that's a pretty good size for a text file. Then in addition, you can cast some of the values and attributes, and we'll look at how to do that, how to basically break up the data that's inside of this variant data type. For those who might be familiar with other traditional data types in a relational database like Oracle or SQL Server, MySQL, this is where you might have seen something historically loaded as a clob or blob type column data type. And so now we've got the variant data type, which is more specific to handling all sorts of different types of data. And so it's been pretty interesting working with this data type. And again, in the new age, I think SQL Server now has an actual JSON data type. I think Oracle has one very similar to a JSON data type. And a lot of times if you do a quick search for like Snowflake variant, you oftentimes see using the Snowflake CLI or some of the client tools like an ODBC connection or JDBC connection or even Python connection, and you'll see them using like the copy into or the put command from the CLI, and those are very relevant. But we're actually for tonight, we're actually going to skip over using the CLI or even a stage. We've got a great meetup video that we did a few months back on using stages, and we also had another one on using Python to interact with Snowflake. So be sure to check those out. We'll post those in the comments when we post this video out on our channel. But for tonight, we're actually going to use just the pure Snowflake worksheets to kind of go over things with the variant data type. Where people are using this in the real world, well, they're using it for, like I mentioned, flexible schema data. So that's really just another fancy phrase for semi-structured, unstructured data, right? Some people don't like that term unstructured because they say, hey, look, any type of data you're gonna be using has some relative structure to it. So let's just call it semi-structured. We totally get that. So let's just stick with the term semi-structured. I think that's supposed to be sensor data, log data, different hierarchies and arrays of data. And so when we look at this, we see JSON seems to be the most popular form of data that we see put into the variant data type. And I don't know if that's because they've got some good concepts for creating like these JSON objects in Snowflake, or JSON just seems to be taking over the world, and XML is on its way out. CSV is pretty straightforward, but we tend to see this also inside of XML also. So XML parsing is still something that's available, and we see this in SOAP interfaces and things like that. So XML is still around, and XML can be handled inside of a variant data type as well. All right. So if there's no questions on really like what a variant is, let's learn what a variant data type is by walking through some just key examples. So what we're going to do is we're going to just take a look at the basics of a variant data type, and I think we can get this done in a relatively short period of time. There's a lot of deep dives and there's a lot of like tentacles to the variant data type, which is actually really interesting because it seems like a data type that's just going to be really straightforward, and be able to just kind of say, hey, I'm loading JSON, let me review the JSON and we're done. But there's a lot of different things you can do with this variant data type that you can't really do with just like a standard integer or string data type. So we're going to review basic JSON file, load that in. We're going to move that into a table with a variant data type, and then we're going to parse the data and try to pull out some relevant information out of that JSON data type as it's in a Snowflake table with a variant data type. So JSON file into variant data type. And so really basic. I think these steps are not necessary. And so before we do that, let's look at some key definitions that we're going to use, and we'll come back to this. So there's no worry. But I just want to make sure that as we're going through the exercise here in the walkthrough, that when you see these, it should like your eyes should perk up a little bit, right? So we've got the flatten, we've got object construct, and we've got basically lateral. And it's a lateral flatten. It's also called a lateral join. And these concepts are actually a little different because, I think in most other systems, we don't see things like lateral flatten or object construct or even flatten really. But I think they're unique to Snowflake. And again, it's all about being able to not only ingest, but provide some capability of like egress into this object format that we're really calling a variant or semi-structured data. So not only say, hey, we've got this other logging system that's building JSON data, and yeah, let's get that into Snowflake, but also being able to say, hey, we've got relational data in Snowflake, let's get that into JSON and let's kick that out, let's egress that out. And so they've provide that end-to-end capability, which is actually really cool. So if we say, hey, let's go ahead and take on this challenge, if you will, and dig into variant data type and querying the variant data type inside of Snowflake, what would that look like? Okay, so let's just go ahead and jump into that. I'm going to open up this spreadsheet here, or not spreadsheet, worksheet rather. And we're going to start at the very top. And I'm going to go ahead and make this a little bit bigger just because sometimes it's hard to see stuff for some folks, and that's okay. So this should be like really big and really clear for anybody that's watching live, or as we get into the recorded video and post this on the channel. There should be no problem seeing this. And if there is somebody who's live here, let me know, but I think this is okay. So what are we going to do? We're going to step through some basic worksheet data concepts here. And if you're familiar with Snowflake, then you should know how this kind of works. And it's really brilliant being able to step through each of the bits of logic that we're going to expose here, just kind of line by line and grouping of lines as we go through and talk through this. So the first thing I'm going to do is I'm just going to kind of set the context to make sure I'm looking at the right roles and the right permissions using the basic use concept. I've got a schema here that I'm just going to make sure is created. And I can kind of expand this over here on the right-hand side. And I can see that I've got a couple of schemas I'm going to create for this exercise. Well, this is actually one of the previous meetup schemas, and this is the new one that we're going to be looking at here, meetup DB, and it's got today's date. Okay, so that is now created, and you saw that there were no tables in there. So I'm going to create this one table. It's called meetup variants. And again, we talked about this last time, really using all of the DDL structure here. I really like to put some metadata into the tables that we create. Here we've got the one column, and it's a variant data type. And notice it's just variant. And what's really interesting is the Snowflake syntax does not highlight this as a special data type. It just kind of keeps it, standard text black and doesn't highlight it. So there's something to note there. I'll run this, and I should get a success message down here. I'll just kind of bring that up a little bit. Okay. And then I've got that note here. I could use copy into or the Snow CLI or the put, whatever, but I'm not going to do that because I'm going to show you guys if perhaps you know this way, perhaps you don't. And so I've already created the table up here, meetup variants. So now what I'm going to do is I'm going to insert the JSON that we're going to be talking about. So now think, this is just a walkthrough, but imagine, this is a set of JSON coming from, some, fire hose. It's streaming in to the system. It's coming from somewhere on some periodic basis, anything like that. And so this particular JSON, what I'm going to do is just one big block of JSON. So it's about, I'm going from line 19. This actually comes from, I think, Rotten Tomatoes. So it's basically looking at movies, what genre, how much did they gross in the box office, what's their score, what's the rating of the movie, things like that. So I'm starting here basically 19 with the initial root bracket. And I'm going all the way down here to line 100 and something. Let's see here. So basically, 255, right? So that's a lot, it's structured, it's a decent amount of JSON. And one other thing I do want to talk about when we talk about JSON or XML, there's this concept called linting, L-I-N-T. And some people might be familiar with it, but what we find is that people want to go to Snowflake for the performance and the output. And there's all these, it's like, how's the sausage made, or, how are the gears, moving inside the engine. And so if you're just a person who's just learning about Snowflake, or maybe you're on the business side, or maybe you're a data scientist who uses Python and you don't know too much about SQL or other formats, it's really interesting to kind of see how you break apart, kind of these internals. And so this, JSON is a loose structure, but there are some concepts to it. So there's tools that they call linting tools that'll help you validate if your JSON is accurate and if the structure is what they call a well-formed document. And if you don't have a well-formed document for, it could be XML, it could be JSON, even though it's semi-structured, there's, like I said, there is still some structure to it. So if you try to load a document, a JSON document that is not well-formed, you could potentially be walking in circles as you're trying to do some of this effort. Just to kind of give you an example, I think Snowflake does a pretty decent job. Here I've removed a bracket, right, a closing bracket for this particular object. And if I scroll back up to the top, I think it'll show kind of like an indication that something's wrong. Maybe I have to do it like on this bracket here. Scroll back down. Yeah, so now it's not giving it to me. I thought it was giving it to me earlier, but you might see somewhere in here where it like turns red or something like that. I can't remember if Snowflake actually does that or not, but if you see something like that, then you know that you could have an issue in your syntax. It'll create a parsing error when it runs, and if you're not too familiar with the syntax of how JSON works, then you could be trying all different sorts of things and never get it to work, all because the JSON, the semi-structured data you're passing in, was never valid. So it's something just to kind of keep an eye out for. And I'll show you an example of a good Chrome plugin that we like to use for linting JSON. So what I'll do is I'll go ahead and run this. My semicolon's down here, so I can run the statement if I'm inside of the semicolon. And it took a minute, but you can see here, it only inserted one row. And as you can see, just even if you're not familiar with JSON, you can kind of see that this is one movie, and then here's another movie, and there's a movie above it. So instead of giving me a multiple rows when I did that insert of that JSON, it actually gave me one big row. And so the time and the place of the engagement of how you're getting your JSON data is not always up to you or your company using Snowflake. So you'll have to potentially adjust for the type of information that you're getting. And the variant data type does a lot to allow you to kind of correct and react to this. So we'll be talking about that here in a minute. And so just to illustrate this, we're going to actually load some other JSON data into another table. So here's another table that we're creating called card sales. And here I'm calling this column source, or SRC, and it's also the variant type. And what I'm doing right now is I'm actually going to load this in kind of all in one statement. So it's going to create and replace the table. And then we are going to basically do like the select insert concept. So we're going to parse column one, which is actually going to be only one column for the source. And we're basically going to do the from values, which is going to load these values. So it's basically doing like we did before. We did a create table, and then we did an insert statement. Now we're going to do a create as select from values, and it's going to take these values, and it's basically inserting them into our table, brand new, all in one statement. So again, these are just cool things, and we're going to post this out on our GitHub. It's completely open source for you guys to use, and everything's self-contained in the script. So it's actually really cool for anybody who's trying to learn JSON, and anyone who attended this session. So here what we've got is a little bit more structure to our JSON. This is probably more what you would typically see from any sort of operational system or any SaaS-based system that you currently use, and you're getting a JSON feed. And the concept here is that you have what we refer to as key value pairs, right? So we've got in quotes here, very nicely well-formed JSON document. We've got, we can see we're going from line 268 to 283. And we've got our date, and again in double quotes, which is a JSON formatting structure. Then over here we've got double quotes, we've got the date, we've got the dealership key, and we've got whatever the value is of that dealership. And then here we've got salesperson, which is kind of that identifier, and then salesperson has an object with these sub attributes, and it's got the ID key with the value 55. Here we've got the customer attribute, and we've got, now when you look at these open brackets, this is what we call an array. And again, some people might be familiar with this, but we're just going to quickly highlight it. And then really anything inside of the bracket is what we call an object, right? So inside of the curly braces rather is an object. And then again, we go with that same kind of logic, key, and then we separate by the colon, and here is the value. So we've got that key value pair again, then we've got a comma for the next set of attribute key value pair, so forth and so on. And so you can see here, this is an array of 3 objects, all with this very similar structure. And then here we've got another array for vehicles, and we can kind of see very similar concept. And then even inside of this array of an object, we've got another array, which is just more of like a string array for any programmers out there. Okay, and then we've got another completely separate object, which could be differentiated based on date or dealership or person or some other factor. And now what we're doing here, as you can see, we're actually creating 2 different rows. So let me just go ahead and insert this real quick. Let me just go ahead and run this whole statement. It's going to create the table, and it's going to do the insert of the records all at once. Okay. So because it was a real join statement, it's actually only running one statement, right? Which is to create table, even though it inserted both records, and we'll show that in a minute. So now that we've got our JSON data sets loaded into 2 different tables, each with just 1 column, and both having that 1 column be a variant data type. Let's go ahead and look what we have in those tables. All right. So the first one I'm going to do is just kind of do a select all from meetup variants. If I do that, takes a second. You can see I get 1 row back, like I told you we would. And you can see we've got basically the same JSON structured document that we had above. It's just now inside of the table in that variant data type. Okay. And then if I do select all from car sales, if I run that, we've got the 2 rows because I actually loaded a different JSON document, right, for each row. So there's 2 documents there. And we can see it's the exact same thing, right, as above, right? So we've got that same, the JSON inserts there. And what's interesting about this is in a standard JSON, it's basically a text document. So if you had a text document, there's not too much you could do with that in Microsoft Word or like a notepad. You can't query that data inside of a notepad application on your Mac or on your Windows PC laptops. So here again, the power of Snowflake is it's saying, okay, great, take that text document in the semi-structured format, no matter where you're getting it from, and then let's go ahead and allow you to query on it, or at least do some other magic on it that relates to the having the benefit of putting it into something of a data store or database. So let's take a look at a couple of different concepts here. So the first one is I'm going to just pull by an individual key here. I think I can still do this. Hopefully I didn't mess up my test suite too badly. Okay, so here now what I'm doing is I'm saying select from this column, and I'm using this initial colon, and this initial colon is basically saying, hey, what's the key that you want to point at? And what's interesting is the key that we have in that first set of data, the one with the movies, there really is no good like generic key. It's not like date or name. It's actually the label of the movie. So sometimes you can look at the JSON structure and say, okay, who created this document this way? And then you have to adjust and adapt to this kind of very specific JSON format. Because in this case, I actually have, the only way I can get the actual value that I want in a very clean way, as you see here, to get the data here, is to call it by the name of the movie, instead of saying, find me all movie that we received the JSON file. Again, we don't always set the time and the place and the structure of the JSON file. We just have to work with it. So I'm going to show you a trick on how to get all the movie names without having to call specific movies. But I want to highlight the difference in the fact that as we're working with data, we don't always set the time and the place and the structure. So we have to be able to roll with the punches and know that we have to, sometimes be creative to get the answers we're looking for. Another thing that we can do is basically set an index. So we can use the brackets instead of the colon to get to the column name or the structure name. And let's see if this one works. So here I get a null because there's really nothing that's telling it that there is an indicator for that initial pointer in that series of data coming from that meetup variance table. But it works if I explicitly give it the kind of the title of the initial object, or the movie in this case. So what I can do, and this is the trick, I guess I put it a little bit higher up in the syntax than I thought. So what I can do is start using something called lateral flatten. And lateral flatten basically creates an inline view of the data based on the output of the proceeding from clause. And so here I can use that the proceeding from clause as the input, and then I can use the lateral flatten to kind of reference the data in a different way. Let me see if this works. Right. So now I can see, I can pull out all of those objects, because remember before, if I just did a select all, it's just one row, just one record in that table. So let me just go back up here, meetup variance. If I just do a select all, it's only one row that got loaded. And this is a very, very common case. So if I actually want to say, okay, in that one row, give me each one of those individual objects, in this case, movies, I have to do something a little special for this particular use case. And so for this particular use case, I can use the lateral flatten. Just run that, takes a sec. And then I can see here that it's actually, this one's actually giving me all the same movies, actually. Just giving me that record, that one row many times. So let me see if I can break that up a little bit. So here, what we have is another way of looking at it, but what we're doing is we're doing syntax a little bit differently, and we're actually trying to pull out the key, and we're going to pull out some of the individual attributes. And so in this example, what we're doing is we're pulling, and we're using some Snowflake specific output parameters. I guess we could call these key and value, because remember we talked about key value pairs before. So we're going to pull those, and we're going to use those very specifically. And here we can pull specific genre information, specific rating information from that individual column. So let's run this bit of the syntax. Okay. And you can see that because, and this was, sorry, this is what I meant to get to. Now we can see each individual movie, the genre for each individual record, or in this case, JSON object, not record, and then the rating if it's there. So a couple things to kind of notice here. Our structure is almost identical here if you look at how we're doing the lateral flattening between line 314 and 323 and 324. But one of the main differences is we're actually having to use the key and the value assigned in order to then get individual JSON objects from that one row using the variant data type. And so this is going to be super helpful for anybody who's actually been dealing with JSON, even just to know that there's complication behind the way you're getting the JSON handed to you and the way you're going to have to present it and interact with it via the SQL. And so one other thing to kind of keep an eye on here is, because you're using semi-structured data, that means that some of the objects, or some of the XML or the JSON or the Avro data, it doesn't necessarily have to have a very rigid, dense structure, if you're familiar with that concept of dense data. And so that means you could have some objects with like 3 attributes coming from your JSON data, and some objects with like 10 attributes, or so 10 key value pairs, right, for that attribute. And that's okay, because you're allowed to do that in a semi-structured configuration. And so here we can see, there's a value for every single key column, which is the movie. So that's super important for the data that we're getting. But in the genre, maybe the genre wasn't specified, or maybe there is no good genre to sum up that movie. So when we get the semi-structured data, that attribute may be available for some of the JSON records or objects, but not all. So in this case, we can see that Snowflake is handling that very well. It's just giving it a null, and it's not causing it. It's not bombing anything. It's not causing us an issue, because we explicitly call the value here for rating. It's not saying not found or anything like that. So that's another benefit, and another, I guess you could say, tenet of using semi-structured data, and that all systems should be aware that that is the case, that there can be nulls, and we're accepting of that, or I wouldn't say nulls, but no attributes for that particular part of the structure of that object where it might be available in some other object. Okay, so let me scroll down here just for a few more minutes. And now we're going to talk about some other just kind of standard scanning of JSON data. Now, this is kind of the more, let's say, perfect world use case of having JSON data provided to you. What we're trying to say here is that your data is going to be fairly well structured, coming in JSON format, or at least in a variant data type, whatever we're loading in there, XML or in this case, JSON, right? And so let's say it's fairly well structured. And what do we mean by that? We mean that the objects inside of the XML or the JSON, whatever the variant, whatever we're loading into the variant data type, let's say that it is going to, for the most part, always have a key and a value. Okay? Where some of those objects could have, like I said again, one object could have 3 attributes and another one could have 10. But let's say they're all going to be labeled fairly well. So if we just scroll back up here to look at the car data, labeling very well. What I mean by that is, in car sales, if we have date as a key, and then we actually have an actual date as a value, dealership, and an actual value here, right? And so that gives us the ability to say, hey, we're looking for dealership, so let's call the dealership attribute, and we should get the respective value for the dealership key. And so when that happens, your syntax looks a little bit cleaner, because it's easier to identify things by having a key and return a value. So here we can see if we use a select statement and we, source is our column name. So remember, our column name comes first, and then we use a colon to then identify what the first attribute we're after is. So you could have nested attributes, and we'll talk about that. Actually, we'll show an example very quickly. So I'm going to run this, and then if I just pull up the results, we can see, again, we know that we have 2 rows in this car sales table on that variant data type column. So we know we can pull out by column, and then our selector, and then we've got our attribute. So these are exactly what we're looking for as the results, and we could validate that up above, but I just showed you, so hopefully you remember what we saw. And then here I can do, again, I can select a little bit of a drill down on that nested attribute. So now I want to go source column, my qualifier here, to the initial attribute, and then I want to see the address for that underlying object, right? But this doesn't work here because this is an array of objects. So I would have to go into that array, if you're familiar with programming, to figure out, okay, we want to see all objects in that array, or do we want to see the first object in that array, which would, say we'd want to call a 0 index pointer for that. But if we wanted to see the actual index, we would just take the first part. We would take the column and the initial selector, or the initial attribute, and that's what we're doing right here. So we're removing that extra dot address. Okay, so if I run this, I can see this is the full array. And again, what do we say if we have an open bracket? That indicates that it's going to be an array, whether it's an object array, a string array, an integer array. And so here we can see we have exactly that. We've got an array of objects, and I want to go ahead and pull in the customer address. So if I wanted to pull the first item in that array, I'd have to do index 0. So I put the bracket there, and now I've just got the first object in that array. And if I wanted to then pull the address from that first object array, I would just type in address here. Oops, caps. And then I could run that, and now I can get the address. And you might be noticing also that I'm getting double quotes around this here. And so that means that the result of what I'm getting is giving me a literal string result. And so in order to actually really turn that into an individual string, I'll have to cast that. I'll have to explicitly cast that to a string data type, because otherwise it's kind of floating either between an array data type, an object data type, or a literal string data type, which is not the same thing as a string data type. So we'll talk about explicit casting here in a moment. And as a matter of fact, let me make sure, yep, I've got one down there below. Otherwise I was going to do it right now. So let me get rid of that. We see that we can get the address. I'll do the same thing here. Just call the name so we can get the name of that first customer in that array. Same thing here. If I want to go look for the salesperson name, I can get that also. And then of course, maybe the question is, hey, are we getting, can we do multiple columns? Because remember, we only have one variant data type column in this table. So if I wanted to select multiple columns, could I do that? Absolutely. Right, so now I can pull out the salesperson name and the customer name, in the same row. And of course I can assign aliases, right? I could very simply do something like that in order to just prove out that basic concept. Something else you might see is something called bracket notation instead of dot notation here for the programmers, even our Python developers. Instead of dot notation, you can use bracket notation. So in order to get this same value here using the colon and the dot, I can just use the brackets. And it's going to give me the exact same value, and I can alias it if I wanted to. And then you also notice again that I keep seeing these double quotes. So as I mentioned, we can explicitly cast the string into, or sorry, the literal string into an actual string object. And you'll want to really pay attention to this as you work with any variant data type or object data type, simply because if you're in a situation where equijoin or comparative analysis, you really do need to make sure that you're comparing the same data type, so to speak. And in order to do that, you want to do an explicit cast to whatever data type you might be comparing or analyzing or using special features from. So here we can see if, let me actually do the same one. Let's do name. And you can see here salesperson name brackets gives you the extra quotes. So if I run this, now you see I don't actually have the explicit quotes here from a literal string. I've actually casted it into a string object where I know it's a string, and now I don't get the double quotes there. And something else to kind of keep in mind is that when you're doing like a copy into or put or something like that from a JSON file, the keys and the names are going to be case sensitive. So you really want to pay attention to that case sensitivity as you're working with the data. So a lot of people, what they'll do is they'll take the JSON table that they've loaded into, and then they'll immediately create a separate table where they've created different column names that are very explicit, so that they won't have spaces in them. They'll be very, very clean, crisp, explicit table names, so that then when they're trying to do any type of work, they either don't have to worry about casting, they don't have to worry about case sensitivity and the column name structure, things of that nature. So that's a very common practice. You could even call it a best practice to do that. All right. And I think a couple of the last ones before we get to some advanced techniques is, again, yes, we can use multiple columns, we can cast accordingly, and we can use that lateral flattening to our advantage when we're working with JSON data here. So here we can see we know we only had 2 rows before with our car sales data, but now I'm using that lateral flatten technique again, like I did before with the movie set data. And now I can see that there's a customer name and an address for each of those references. And that's pretty cool because I could use a lateral flatten. It's basically breaking out those objects again, as we saw in the earlier example. Same thing here, except now what we're doing is we're kind of complicating that example, and we're saying, all right, let's say there's multiple sub objects inside of our JSON data set. So how could we look at those data sets in the same row if they're related to each other because of the kind of the hierarchical nature of the JSON data? And in this case, we can just simply run multiple lateral flattens. And you can see here now we're aliasing our lateral flattens because they're basically like subqueries, right? And we can reference those up here in the select statement. Here's the VM, here's the VE, and we're referencing, and we're even doing an alias. So if we run this, we should be pulling in, all the extra data that we wanted. So now you can basically say, hey, here's the make, here's the model, and then for this particular set of records, here's kind of like the sub array that was there of the extra items purchased for that particular vehicle. Right? And we could get the customer name and all that if we want to do that as well. And the last item, just to talk about one more way we can get at the JSON data is to actually use this concept called Git Path. There's actually another concept called Git inside of the usage of the variant data type. And but Git Path is very similar. It's actually kind of like a one further step from just using Git. And you can see here we can use the as the first argument, we can use the column name. As in the second argument, we're really just passing in some sort of path or some sort of index, if you will, of where the Git path should look inside that JSON or the variant data type to get the result it's looking for. So if I ran this here, it pulls back the 2 rows because it's a really simple Git Selector, and it's just going to pull back the 2 kind of cars that were sold, right? Honda and Toyota. So pretty straightforward. There's some other advanced techniques here that we could use with JSON, and I'm not actually going to go over all of these except one. And I'm going to go over this one here. And again, you guys, this is going to be open source, and you guys can get access to it once we post everything on the channel. But I will talk about this one called Object Construct. And if you remember at the very beginning, I said that Snowflake's done a great job of allowing you to ingest the data, but also to egress the data out of Snowflake. And in this case, so ingress JSON, for example, but it also allows you to produce JSON from a standard relational structure. So I have over here in our other database, just some basic sales data, like sales order header, sales order detail, things like that. So I'm using a common table expression here. And what we're doing in that common table expression is just really just pulling out a couple different queries, right? One from the products table, one from there's a sales reason table, and we're kind of joining these on order ID. And I think right now we don't have any data loaded into the product table for some odd reason. So we're actually just going to be joining sold reason and the sales order header table, I think, yeah. And so what we're going to do here is use this object constructor function, if you will. And what it does is it constructs an object. So remember the several data types we have in Snowflake for working with semi-structured data, or arrays, objects, and variants, the variant data types. Those are the 3 key ones. And so what we're going to do here is we're going to create an actual object. So this is not going to, it should not generate a variant data type. It should create an object data type. But remember, variant data types can hold object data types. And then, of course, most of the data you work with in JSON, you're typically working with objects, at least with key value pairs, or attributes, as you might call them. So what we're doing here is you can see this with our single quotes. That's giving an explicit label. So this is almost like hard coding. If you're writing regular SQL, if you did like a select with single ticks, whatever's in that is that value, and that's like hard coded. And it's exactly what we're doing here. So we're basically hard coding a key, and then directly next to it, we're adding some sort of value. And in this case, this value, because you can see here with the A reference from the alias from this table, it's actually providing that value from the select statement. So it's basically going to select all records from the header, and it's going to hard code this key, sales order ID. It's going to get the value for that row. It's going to hard code sales order number. It's going to get the sales order number value from the table, and basically align it with that using the object construct. So one of the other thing about object construct is it will give you an error, I think, if there's not an even number of basically columns, if you will, in the structure, or arguments would be the better term. So if there's not an even number of arguments, it's going to give you an error, simply because you should have a perfect key value pair sequence created. All right, so enough of the technical overload. And then what we're going to do is it's a simple common table expression. So we're going to join to the sold reason alias CTE above. And so if we were to run this query by itself, let me just do that. I should have had the exercise set up that way. If we just run this and look at this table by itself, I do a simple select all from this table, what do I get? I get a basic structured, right, relational row column format, about 32,000 rows. Okay. Then if I run this statement that's going to produce the object construct, what do I get? Let's run that. Okay, less rows because of the way I'm doing the join. I'm joining to the actual reason, so I get less rows. But now look what it's done. It's created 23,000 rows out of whatever should have been 35,000 original rows. But it's, like I said, the join is reducing the count. And now if I click on this, it's giving me a 1 row for each. So now I've got that underscore sales order ID. So this is my key, and this is the value for that row coming out of the table. I've got the date, or the due date as I called it. Here's the value. Is an online order. This was the flag, and so forth and so on. And this is actually interesting, right? This is the array that I created because I knew that each one of those sales order headers has one or more records in the sales reason table. So what I did is I created an array using a special function I'll show you here in a minute to kind of give me that sub element. So this is all in one row. This is now JSON, perfect, well-formed JSON. So I can now send this to any other system like a logging or text system that can then parse this however it wants, if it can only consume JSON or something similar to that. Maybe like a REST API if I wanted to, for example, be already like perfectly formatted REST API response. And so again, just up here, what I did for the parsing multiple rows from the sales reason table is I use this concept called Arrayag, and then I use the object construct method inside of that. So this basically pulls multiple rows from an individual table, creates an array out of it. I've got this ID here, which references the join down here at the bottom. And then that's how I get that sub array inside of that JSON that I just showed you. So a lot of overload, and I've already gone much over the original time slot that I wanted to. But I think what this gives credence to is that working with JSON data has just a lot of tentacles. There's so much you can do with the JSON data inside of variant data type. So let me recant that last statement. Working with variant data types, there's a lot of legs, a lot of tentacles as you work with objects and other structures that are semi-structured data constructs. And so with that, let me just revert back over here to the slides, and then we can go ahead and start wrapping up. Okay, so we went through a lot just now, and what we really learned was that it's pretty straightforward to set up JSON data. Again, we'll send out the links to look at some of the old ways some of the other ways, not old ways, that we did it using the CLI or stages to get JSON data into Snowflake. But this way, we just went through some simple testing, loaded some simple data sets, and it worked very well, as you saw. We also loaded the data into the variant data type. Well, we talked about that. Ran several parsing queries, gave you several use cases and scenarios, used flatten and lateral join. And then we also discussed the idea of linting, right? And you can kind of see this very generic, Wikipedia output here on what lint or linter or linting is. Something to definitely take a look at. It'll save you loads of time as you're working with these different data sets as you start ingesting things into Snowflake. All right. So with that being said, I think we'll give like a couple minutes for any Q&A, and if there's no questions, we'll just push to wrap up and then move forward with talking about some of our upcoming events. So let me just pause there. That was a lot of information, and we'll be happy to do any breakouts. Obviously, we can connect offline, and you guys obviously know how to get in touch with us as the Carolina Snowflake Meetup team and AICG. So let me just pause there for a second and see if everybody received that kind of loud and clear. Okay, great. Well, just a reminder, again, Data Lakehouse is the way forward in the data cloud. And if you're interested, check out datalakehouse.io. And we've got a few great upcoming events happening for the Carolina Snowflake Meetup. And so definitely reach out if you have any topics you want to see. We're very social. We love to hear from everyone on different topics. The more you give us feedback, the more we get energized to create more of these. A lot of great information, and we know we're helping people. We've had a lot of great responses already on the group and how it's been really helping people to evolve their skills and help them in real world scenarios with their companies and things of that nature. So, well, let's just go ahead and wrap up here. So thank you for joining, and we will see you at the next meetup. Have a
Great job. Thank you.